it's brand new is because they didn't know how to separate matter into its different substances. They got mixed up. We'll see the two categories here. They thought the two categories were all one category. So there's two categories here, mixtures and pure substances. Okay, prior to about 1800, they thought mixtures and pure substances were the same. Now, as they started dissecting chemistry and having a better understanding for what they were looking for, they realized that you could split matter into two components, and that chemistry really only dealt with one type of matter. Okay, so here's this dichotomous chart. So matter, and there's two types of matter, mixtures and pure substances. And watch the video going over that. Okay, so this video. But so the difference between pure mixtures and pure substances, mixtures, one of the things, you can never make them the same. And basically mixtures are just about everything in our everyday world. So if you bought Diet Coke, every time I drink Diet Coke, it tastes the same, so I think it's pure substance, all right? But they can never make it the same. If you read the ingredients, they try to put the same amount of ingredients in here all the time, they can't. And measuring, there's always imprecision in measuring. So this is not, even though it tastes like the same and looks the same all the time, it's not, okay? But a pure substance, you will always make it the same. For instance, water, you can't screw it up. It's always going to be two hydrogens and one oxygen. And that's really one of the big differences between mixtures and pure substances. The other thing is that pure substances, to make them and break them, you need chemistry. So what's another definition for chemistry? What is needed to make or break pure substances? All right. Now, mixtures, you don't need to do chemistry. What you do is you just take to make the Diet Coke, well, you just take the ingredients in here, throw them in together and mix them up, and you got your Diet Coke. There's no chemistry. Okay, so chemistry is making or breaking pure substances. Okay, now let's stick with mixtures. Mixtures, there's two kinds of mixtures. There's ones that look like the same all the way through, and those called our homogeneous mixtures. And that's what this guy is. Diet Coke is a homogeneous mixture. And well, I mean, you might see bubbles on top, but if you look at it, it looks the same throughout. Okay, and then you have heterogeneous mixtures. I'm a heterogeneous mixture. You can see my skin, my hair, and everything else. And you see that I'm not a smooth, continuous, uniform, all right? But the thing about, so this homogeneous and heterogeneous is that you can see the difference between the things that make it up. Pure substances will look like homogeneous mixtures. And that's a problem, because that's one of the reasons why chemistry didn't go very far 100 years ago, is whenever they look at a homogeneous mixture, they thought it was a pure substance, but it wasn't. Okay, so pure substance and homogeneous mixtures can look alike, because this looks like it can be pure, it tastes like it's pure, like it's all one continuous thing that's made out of one thing called Coke, right? So pure substance and homogeneous mixtures can look alike, but they're different. Okay. Now, how can you tell the difference? So somebody gave me this and said, how can I tell if this is a pure substance, a homogeneous mixture? It sure looks pure. What you do is you take some physical processes, like a hammer, and there's this whole list of physical separation processes. There's a boiling, freezing, filtering, physically taking a hammer, all kinds. So there's there's a list of these physical ways that you can separate things. That's not chemistry. I would do that first with this. In fact, what I would do with this is I'd boil it. And if I boil it, which is not chemistry, boiling is not chemistry, because when you boil something, what you're doing is you're not, like when you boil water, you're not breaking the water into hydrogen and oxygen. What you're doing is you're breaking the water molecules apart from each other. So when you have liquid water, there's water molecules that are all attached to each other. And then when you boil them, they separate from each other. So that's not chemistry, because you're not making or breaking a new substance. Okay, it's water, still water. So when you boil something or freeze it, you're not doing chemistry, you're doing a physical change. So first thing I would do with this is I might boil it. And then when you do that, actually, I don't know if you ever boiled salt water before, or is that, wait, the water will go off and you're left with salt. Okay. So you would do the same thing with this. When you do it, you'd be left with some brown stuff. And then you could actually collect the water as it boils off. And then the next thing you would do, so right off the bat, you would know it's a mixture, because you're able to separate it. Okay. So that's what you do. So if you were to tell if you have a pure substance or a homogeneous mixture, is attack it, try to break it apart using physical separations. And if it does break apart, you may have a pure substance. Okay. Not 100% sure, but you may. What you do is you keep on breaking, try and breaking it. Blah, blah, blah. Okay, so what I just say chemistry was about? Chemistry is, one of the definitions of chemistry was it's what's required to make or break pure substances. So what branch are we going to work on? We're going to work on this branch over here, pure substances. So chemistry is going to be, chemistry is going to be over here. Now, we will deal with these guys over here in some degree, but not really. All right, so we're over here, so this is where we're going to go. So what we're going to do is we're going to work with pure substances, because that's chemistry. And then what you can do is you can break down chemistry into different parts as well. And we can break it down into two things, compounds and elements. We'll show that. And then what you can do is you can break it down into the, this should be over here, but the elements into some atomic particles, protons, electrons, and neutrons. Okay, how's that? Again, watch the video and okay, there's the mixtures, here's substances, physical properties. Okay, chemical and physical properties. Physical property is simply what we notice about something, how it smells, what it looks like. Also, maybe things like boiling point and density. Like I said, boiling point is not chemical property, it's a physical property. Like water boils at 100 degrees Celsius, while ethanol, which is, we'll talk about that, but it's the main component, and alcohol, like beer, has a lower boiling point. And that's how we can actually tell we can tell the difference between ethanol and water is boiling point. Extrinsic just talks about it's dependent on its mass. Chemical property is a little bit more difficult. The chemical property is one you have to do chemistry on something to determine its chemical property. Okay. Like a chemical property of paper, which is made out of glucose, is that when you mix it with oxygen, it turns into carbon dioxide and water. Now, you don't have to know that particular one, that's an example. All right, so I just went over that, about homogeneous and pure substances. Pure substances, okay, so let's get into that. So there's going to be, all right, now this is really important, and this is going to be on the definitions, which I'll go over the, I'll show you the Quizlet in a minute or two. You got to know the difference between atoms and molecules. Okay. And atoms are the individual basic entity of an element that has the same chemical properties as an element. Okay, what is the element? An element, so we didn't know things were made out of atoms 100 years ago, but we knew that things couldn't be broken down anymore. For instance, if you had a piece of gold, we knew that we called it gold, and we said it was an element because it couldn't seem to be broken down into anything else. We didn't know that it was made out of individual parts. It wasn't until early 1800s that we realized that elements can be broken down into parts. And so the individual parts of an element are called atoms. Okay, now, what the thing makes, we'll go over this down a little bit, is all the atoms of a particular element will have the same number of protons.
Say that again, please?
The atom, the types of atoms of an element, what makes them who they are is how many protons they have. Now, if you don't know what protons, that's fine, but just let you know. For instance, if we look at your periodic table, okay, there's things on here, and you'll see this on the videos as well in the class. You see this number above. This number here is called the atomic number, and this number never changes for the element. It's always the same, and it tells you how many protons it has. So potassium, K, always has 19 protons. Now, this number here is called the atomic weight, and we'll spend time with that, but that can change. And that's because there's two other components called neutrons and electrons. Those numbers can change. They don't have to always be the same. So the identifying factor of an element is how many protons the atoms have. That's its identity. Its identity is how many protons it has. And that number is also called the atomic number. Okay, so atoms are individual things that make up elements. Now, molecules are combinations of atoms. Okay, so molecule is a combination of atoms chemically bonded, okay, or in a definite ratio. And a couple of examples of that. For instance, water is a molecule. It's made out of two types of atoms, elements, two types of elements, hydrogen and oxygen, and it has two hydrogens and one oxygen. That is not water. They have they both have the same elements in them. This guy water has a very unique composition, two hydrogen, one oxygen. Now, they are combined by a chemical interaction. We call that a bond. Chemically combined, right? So they're chemically combined. Right, there can be two types of molecules that we can think about. You have molecules that are made out of the same element, like O2, N2, H2. These are called elemental molecules, because they're molecules. Molecule is two or more atoms chemically combined. An elemental molecule is where the two or more atoms are the same element. Okay, now the other type is called a compound. That's where the molecule is made out of different atoms or elements. Okay? And they're called compounds. But they have the same features. They're chemically combined in a specific ratio. So you could read that. I don't know if it's how important it is. Go ahead. All right. Well, it is. Okay. So law of multiple proportion just says that multiple proportion says that hydrogen and oxygen actually can come in different ratios, and you can have different substances. Okay. This is water. This is hydrogen peroxide. So even though they have the same elements in them, if they come into different proportions, you can have different atoms of the molecules. This doesn't exist. This is a lie. This is alternative fact. All right. Elements also, elemental molecules sometimes can be more than one type of molecule. For instance, sulfur can be found as S2 or S8. Carbon can be found as like diamond or graphite, or different other kinds. But so if you have a diamond, it's all made out of carbon. If you have graphite, it's all made out of carbon. It's how they interact with each other in a number of atoms. Those are called allotropes. Okay, so the first quiz has to do with this video. Okay, so now let's go to the let's go to the Quizlet. All right, so when you go to Quizlet, what I've done is I've created some flashcards that we'll go over that PowerPoint, and we'll focus on the definitions that you need to know from that PowerPoint. Okay, so let's go over that. Now, use this as a method to learn, so they're just like flashcards. You know, on one side you got one thing, and on the other. So two or more atoms chemically combine in a specific ratio. Right? What is that? Two or more atoms chemically combine in a specific ratio. Element? Let's try it. Two or more atoms chemically combine in a specific ratio.
A molecule.
Molecule. Now, they could be an elemental compound. So it's not. So one thing it's also is that, just to let you know, and you'll see how this works. Is that all compounds are molecules, but not all molecules are compounds. Okay, it's like saying all cows are animals, not all animals are cows. All right, so if you have, what you can do is you can think if you have a subset called molecules, you have something called molecules, and then part of that are to be compounds. And another part of that will be elemental molecules. These would be like H2O, these would be like O2 and so forth. Okay. So you see a definition here in a minute, which will almost be the same, but let's say two or more different atoms. That will be a compound. And then you flip it, and there you go. What's an atom?
Individual basic entity of an element that has the same chemical property as an element.
And also you might want to say Well, let's see what the end is.
I was just reading whether it was good down.
All right, and then it's photon and electron detections.
Oh, yes.
So what you did was good, that's fine. Make sure, all right, so make sure is,
Being broken by physical means, and then the final composition.
yeah, so let's take a look at the definition here. A combination of two or more substances that are not chemically combined. So a molecule is two or more atoms chemically combined. A mixture is two or more atoms or substances that are not chemically combined. So mixtures and compounds and molecules can get you can kind of get them mixed up because they're both made out of things. So a mixture is made out of things, but they're not chemically combined. Another thing about a mixture is you never make it the same, and you always need physical properties to make it. Pure substance, okay. One thing I didn't say is that when you do have a pure substance, it has unique chemical and physical properties. So oxygen, the way that oxygen behaves with glucose, that's the only way that it does. Compound, a molecule composed of two or more different elements. Now, notice the word it says molecule, all right? So right away, when I say molecule, I'm saying it's a pure substance, and it has a unique composition. Okay, because this is a compound, that composition is two or more different elements. So it says it's a molecule. So when I say the word molecule, that automatically tells me it is a pure substance that's made out of a unique combination of elements, and they're chemically combined. But what makes it different than an elemental compound is that it has different elements, like water, H2O. Okay, an element. Now, one of the key things here is, like, the only way you can make it is using chemistry. And this up here can't be broken in the other element. For instance, oxygen cannot be broken in nitrogen. And it's specified by the number of protons, which we also call the atomic number. Chemical process, simply what makes and breaks pure substances. Physical processes, what makes and breaks mixtures. Okay, ionic compound. Now one of the things I didn't go over, but if you go to PowerPoint, when it talks about pure substances can be broken into elements and compounds. There are two types of compounds. There's ionic compounds and there's covalent, and we'll be spending a lot of time on that. But an ionic compound is composed of a positive charge, electrically charged metal, and negatively charged non-metal. Okay, so here's, need to look at the periodic table. And this isn't, I don't think this isn't on that video, but that's what's on anyways. The periodic table is basically broken into two parts. We have metals and non-metals. Not everything left except for hydrogen is called a metal. Everything right of that zigzag line is a non-metal. Okay, and you'll see about the charge down the road. Well, what you need to know is that the periodic table is broken into two parts. You have your non-metals and you have your metals. And we'll go more into, I mean, right off the bat, if I said, I showed you something, you could probably tell me if it's a metal, like if I pull out a penny and I showed you, and it goes, is that a metal or non-metal? I mean, I'm not trying to trick you. So, covalent compound, okay, is a compound made of nothing but non-metals. Hydrogen is, even though it's on the left side of the table, it's considered a non-metal. Right, so I said everything on the left side is non-metal. Hydrogen is weird, and it actually has dual properties. Sometimes it can be metal, sometimes non-metal. For our purposes, we're going to call it non-metal. So water is a covalent compound because it just has non-metals. If it has both of them, if it has a metal and non-metal, then it's ionic. Now, if it just has metal in it, it's called a metal metallic compound. We're not dealing with those. Properties of matter, volume, inertia, mass, inertia. Diatomic molecule. Okay, diatomic molecule is a type of elemental molecule. So diatomic molecule is a type of elemental molecule where it's only made out of two atoms of that molecule. For instance, O2 is called a diatomic molecule. Di means two, atoms, it's a molecule. Turns out the air that you're breathing right now, the oxygen that you're breathing is O2. The air that you're breathing is about 70% nitrogen, that is N2. So in this class, we'll talk about oxygen, and you'll see down the road, are you talking about the element or the molecule? Okay, so we'll see how that works out. So you'll have to ask me. Are we talking about the element or the molecule? Or the compound, the diatomic molecule, or the element? It turns out, we'll see this in the next video, is that the diatomic molecules, there's 7 that I want you to know. There's nitrogen, oxygen, chlorine, bromine, and iodine. Okay, and if you notice, that looks like a 7. And that, okay. So there's not, and nitrogen is N2, O2, F2, Cl2, Br2, and I2. Those are the 7 diatomic elements. Elements. Anybody got questions? Do you see where you see them on the periodic table? They're over on the right, and it kind of looks like a 7, like that, down. What's wrong with what I just said?
7.
6 and 7. So what are the 7 for? Hydrogen. So I like the little 7, but there's not 7 there. Okay. So if I ask you what is the chemical formula for fluorine, let's say F2. And you're going to see those words I just used, chemical formula and chemical name, is going to be a big deal over the next couple of weeks. Noble gases are elements that are in the far right hand. they call noble gases because they seem to be, we're perfectly happy, we're the king of everything, and we don't need anybody's help. Okay. We're gonna find out that's kind of a myth, but that's why they call them. So they don't form compounds, or they don't form molecules usually. So all those noble gases don't form molecules usually. They're pretty happy all by themselves. Reason why things come together, because there's unhappiness. And what that means by unhappy is, if I ask you what makes you unhappy across the board, most people would say, I'm stressed out. Okay. And I go, what would make you happy? Less stress. When we talk about atoms and molecules, and when we talk about happiness in chemistry, well, things in chemistry want to be happy. They want to usually reduce their stress. And so what stress is pent up energy. And we call that potential energy. So when a substance comes together and forms a substance, what happens is it's released stress. So what happens for chemistry, why these things form the way they do, is to release stress, or even to make happy. The noble gases don't seem to have any stress involved. Okay, so what do I say about? They're the 8th column and the 18th column. I gave you more information about them, but that's it. Halogens. Halogens are in the 17th column. Okay, you may have heard of halogen lights and things like that. So halogen lights have one of those elements in them or more, like it might have chlorine in them or fluorine and so forth. And it gives them their color property. Alkaline metals are in the first column. Okay. I don't know if anybody's ever heard, look down the side of the battery, it says alkaline battery. All right. Now when I was growing up, I told you I grew up in Detroit. There was a baseball player named Alkaline that had this, and I always look at the battery and goes, oh, Alkaline's batteries. Okay. All right, so, and this is the first column. Okay, so. Alkaline earth are the second column. Representative elements, and these guys, actually these definitions are going to be pretty short-lived. After the first few, maybe the first month, you'll hardly ever hear me talk about them again, but I want to still introduce you. Representative elements are the first 2 columns and the last 6. Okay, now if you notice, the thing about this so far, when I've talked about these last 5 or 6 things, they all relate to columns.